Stop everything you're doing and look up, because the universe just threw us a massive curveball. For decades, we thought we had a handle on how the cosmos expands, thanks to Einstein's math. But what if the constant holding everything together isn't actually constant at all? Recent data from the DESI survey suggests the universe might be changing its speed limit in ways that break our current understanding of physics entirely. Welcome to SciNova, where we explore the mysteries that keep astrophysicists up at night. Today, we are talking about a scientific bombshell that dropped in early 2025. It's about dark energy, that invisible, mysterious force that's pushing the universe apart. We used to think it was a steady, unchanging pressure, but new evidence is suggesting that dark energy might actually be evolving, changing its strength as the universe ages. To understand why this is such a big deal, we first need to talk about the hero of our story, the Dark Energy Spectroscopic Instrument, or DESI. This isn't just a single telescope. It's a massive, complex machine designed to map the cosmic web. DESI uses optical spectra from millions of galaxies and quasars to measure exactly how dark energy has been affecting the expansion of the universe over billions of years. Think of DESI as a cosmic surveyor. Imagine trying to map a forest while you're standing on a moving platform that's constantly expanding. That's what astronomers are doing on a galactic scale. By looking at the light from millions of objects, DESI creates a 3D map of the universe's history. This allows us to see not just where things are, but how fast they are moving away from us at different points in time. The scale of this project is absolutely mind-blowing. In its first major data release, known as DR1, DESI observed a staggering 18.7 million objects. We're talking about millions of galaxies and quasars, each acting as a tiny beacon of information. This massive dataset provides the most detailed look yet at the large-scale structure of our universe, giving us a statistical power we've never had before. But the data didn't stop there. Following up on that incredible foundation, Data Release 2, or DR2, expanded even further. By utilizing 14 million galaxies and quasars for baryon acoustic oscillation, or BAO, measurements, scientists were able to refine their rulers for measuring cosmic distances. These BAO measurements are like standard marks on a ruler that allow us to see how the fabric of space itself has stretched over eons. So, what did all this massive amounts of data actually reveal? This is where things get spicy. For years, the standard model of cosmology relied on the cosmological constant. This idea, championed by Einstein, suggests that dark energy is a constant, unchanging density of energy that fills space. It's a smooth, predictable force that stays the same no matter how much the universe expands. It was the bedrock of modern physics. However, the initial data from the DESI survey, published in early 2025 in the Journal of Cosmology and Astroparticle Physics, has thrown a wrench in that machine. The results suggest that dark energy might actually be dynamical. This means it isn't a constant. It's something that can change its strength over time. Instead of a steady push, it might be more like a tide that rises and falls, or a force that grows or weakens as the universe evolves. If dark energy is indeed changing, it changes everything. It means the speed limit of the universe's expansion isn't set in stone. We might be living in a universe where the acceleration is speeding up or slowing down in ways we never predicted. This would mean our current mathematical models, the ones we use to understand the birth and death of the cosmos, are incomplete. We're looking at a potential paradigm shift in how we view reality. Now, scientists don't just take one survey's word for it. To make sure this wasn't just a glitch or a fluke, the DESI collaboration is playing a high-stakes game of cosmic detective. They are combining their findings with data from the cosmic microwave background, the afterglow of the Big Bang, and observations from Type Ia supernovae. By cross-referencing these different clues, they can see if the evidence for changing dark energy holds up across the entire history of time. Think about the implications of this. If the cosmic microwave background tells us how the universe started, and supernovae tell us how it's expanding right now, and DESI bridges the gap in between, we are finally seeing the full movie of cosmic evolution. If the dark energy tide is changing, we might even be able to predict the ultimate fate of our universe. Will it expand forever until every star goes dark? Or is there a different, stranger ending waiting for us? Of course, we have to be careful. In science, evidence suggesting isn't the same as absolute proof. The DESI results are a massive hint, a strong signal, but they aren't a closed case yet. There is still a lot of scrutiny, a lot of peer review, and a lot of more data to be collected. But for the first time in a long time, the scientific community is buzzing with the possibility that the textbooks are about to be rewritten. We are living in a golden age of discovery. Every time we think we've reached the edge of what's possible to know, a project like DESI comes along and pushes the boundary even further. It reminds us that the universe is far more complex, far more dynamic, and far more mysterious than our simplest equations can ever capture. The mystery of dark energy is far from solved, and that is exactly what makes it so exciting. What do you think? Is Einstein's cosmological constant a mistake, or is there another explanation we're missing? Let us know your theories in the comments below. We love a good cosmic debate. If you enjoyed this deep dive into the changing nature of our universe, make sure to hit that subscribe button and ring the bell so you don't miss our next journey into the unknown. Thanks for watching SciNova, and keep looking up.